Recognizing the increasing significance of geospatial data and our expertise in OpenGL, DirectX, C, and C++, the team at VoidStarIndia embarked on exploring geospatial data in detail. The exploration started by examining the Common Database, CDB. A few CDB specifications were studied to specify the rules for organizing geospatial data. Subsequently, the models and terrain data were selected to parse the CDB and extract its mapping. An entire .flt parser was written to read the model data using Presagis's OpenFlight API. The next step was to parse the terrain data, which was possible by writing a native code in C++, using GDAL API for the imagery and height map data. Following are some of the concepts we used to achieve the above: elevation data. It is height map data that is given in CDB data. We read it through GDAL API. This gives a mountain, uneven surface field to plane mesh. Texture application. The geospatial data gives satellite imagery, which is applied as texture to terrain, which makes it more realistic. Tessellation. The terrain is made up of triangles. The more the triangles, the imagery or texture looks sharp. For that, used tessellation technique of computer graphics. It is implemented in OpenGL. Load balancing. This is related to loading LODs similar to loading levels. Loading of data becomes difficult with an increase in its complexity. This inflates the tessellation details, making loading imagery into memory heavier. The overall process, along with rendering in real time, maximizes the overall cost. To balance such load, the data is rendered using parallel processing through a set of vertex shaders, tessellation shaders, and fragment shaders. This process has assisted us in easing out the concept of geospatial data, along with the technical way to use and render it.